Okay, so we talked a little bit about radians yesterday, what they are, how they're just a different unit for measuring angles, just like the difference between inches and centimeters. They measure the same thing, but they're different sizes. And 1 radian is a lot bigger. It takes up a lot more of the circle than 1 degree. And we talked about where the radian comes from, which the history of things is certainly important, but for being successful in this course in terms of answering questions correctly, probably not so much. And we talked a little bit about, thinking about where the degree came from and why it's defined the way that it is. We talked about the radian for sure, did a little bit of work converting so that we get used to the idea of working with radians and a little bit of what they are. And now we're going to dive in and actually start solving problems with them. The same kind of problems, by the way, as grade 11, no difference. Nothing here we do is different from what you did in grade 11, except that all the angles are given as radians and all the angles must be done as radians. Remember what I said, it's fine in your head. In fact, I would encourage it, if that's where you're at, to do the conversion and think about it. Remember, I've talked a lot already about how visualizing these things is important. And we always draw these little sketches when we're doing trigonometry. And so you have to know about how big that angle is to be able to visualize, to solve these problems. So if you have to convert to degrees to do that, by all means do it. But there's tricks of the trade that we're going to go over that help you get through it. And in fact, for some of you, you might even like radians better. I mean, eventually it does kind of get easier, and there's things about it that are easier. Okay? Gesundheit. All right, so special triangles again, draw them out, and let's label them. So the first one on the left here is comes from the equilateral triangle, and then we cut it in half, right? And when we cut it in half, what do we get? We get a right angle right here. What's that? How much is a right angle? 90. What's that in radians? Don't shut it out. Pi over 2, how'd you get that?
180 divided by 2.
Nice. Remember that thing that's so important is 180 is pi divided by 2. How many people on that learning goal, by the way, for that last question? 0? Where you're like 0 times pi over 180, and you go in through all that, and like, okay, let's figure out what it is. Oh, it's 0. Of course it's 0. 0 centimeters is the same as 0 inches, isn't it? 0 radians and 0 degrees would not have to be. Anyway, it's interesting, right? But funny. Okay. So if we have an equilateral triangle, this angle down here is going to be 60. But what's 60 in radians? Somebody else? Yeah. Pi over 3. How'd you get that? Nice. And then the last one, if I think about 90 and 60, what's left? Because they have to add up to 180. So 30 is left. So what's 30 as in radians? Yeah.
Pi over 4.
Cool. That's fine. Pi over 6. Good. Show you something kind of interesting. If I were to write pi by 3, but with the denominator of 6, what would it be? 2 pi by 3? Sorry, 2 pi by 6. Denominator of 6. Yes? You happy with that? 2 over 6 is the same as 1 over 3? Oh, thank you. What about, so then this is 1 pi by 6? Right? So how much would the last one be? 3 pi by 6? 3 pi by 6 plus 2 pi by 6 is 5, plus one more 6. 6 pi by 6, that's pi, that's 180. Right? Still got to add up to 180 in a triangle, don't they? If you have the common denominator, you can kind of see that happening, how that all makes sense. Pi by 2, pi by 3, pi by 6, those ones do certainly go together. Kind of interesting. Okay. Oh, and can't forget this. What about the side lengths? Well, this side length is 2. We start with that. which means this is half, so it's 1. And then Pythagorean theorem would tell us that that one's root 3. And you just want to memorize that, and you got to get them in the right spot. And I absolutely do see people putting them in the wrong spot, so don't take it for granted. You got to know it. Okay? Second triangle. Where's the right angle? It's up here. Right angle is pi by 2. Right now, you can tell people are still converting, like, well, I take 180 and I divide it by 2, but eventually you just know that a right angle is pi by 2. That's what it is. That's when you're starting to become bilingual in radians and degrees, right? And then what about these other two? They're equal, and they're 45. We know that well. So what does that work out to? Pi by 4. Thank you very much. And our side lengths are 1 and root 2. Happy with that? So now we have two new triangles. Again, you want to draw them out, label them a few times so you get the right ones in the right spots. Very easy to get these ones wrong because 6 is bigger, so you put it in the bigger angle. But if it's in the denominator, it's making the whole number smaller, so that's the smaller angle. That's just an easy mistake to make, even if you're good at this stuff, moving quickly on a test, and your brain is thinking about next steps of the question, and you make that silly mistake. And then once you make that mistake, all your answers are based off of that triangle that you drew. You know what I mean? And all of a sudden you're getting a few answers wrong because you drew the triangle once and you made a little mistake. It happens. Not the end of the world, but if you can avoid it, it's kind of nice. All right, so here we go. We're getting into it. Our first time doing an actual question. And notice that it's given in radians. For the first one, let's think about the degrees. But then we're going to talk about how we could do it in radians. So what is 4 pi by 3 in degrees? 240, how'd you get that?
Pi by 3 is 3 times 4.
Nice. Okay, so it's 240. So how do I solve a question like this? What do? There's not necessarily a certain first step that you would do. So I'm going to start by drawing out the grid. And if I'm 240, I'm here. I'm going to redraw that because it's a little bit more like that. So if this whole thing is 240, then what's this part? 60. And what is 60 in radians? Somebody else? Pi over 3. I'm going to give you a little hint. Finding related angles is really easy with radians because it's basically always the denominator. If it's 4 pi over 3, 5 pi over 3, 7 pi over 3, pi over 3 is going to be the related angle. So that part, that's actually easier, right? Watch this though, just so you can put your pencil down and watch. If I count, I'm going to count in radians. So this would be 1 pi by 3. Remember, we're talking 60s. 2 pi by 3, 3 pi by 3, that's right there, and 4 pi by 3. 4 pi by 3 is one more pi by 3 than a whole. 3 pi by 3 is 180. That's like a really good place to be thinking of. And 4 means I'm one more than that. So I'm in the third quadrant. And eventually I think that's how you're going to be counting and figuring out which quadrant you're in. It's kind of thinking about how many parts of the whole do you have. Everybody get that okay? Well, I'll do it again. So I went 1 pi by 3. I'll do it again. I went 1 pi by 3, 2 pi by 3, 3 pi by 3, and then 4 pi by 3. And so there I am in the third quadrant. Okay, so now we've got our related angle. Okay, so, and we know that, oops, almost missed that. That cast, we're talking cos here, and cosine is negative there. So what are we going to write? We're going to write this is equal to negative cos of pi by 3. So notice, even though I'm thinking in degrees a little bit, I'm writing my answer out in radians. That's what we need to see for a test. if you're going to get any marks. Now what do? I go up to my special triangles, figure out which one I'm in. Well, I'm in the one with pi by 3. And cosine of pi by 3 is adjacent over hypotenuse. So it looks like 1/2 to me. And we have the negative, so this is equal to negative 1/2. Any questions about that? Before we did that question, I meant to do this, but it's a fine time to do it now. Before we move on to the next one, we're going to do something, though. We're going to pull out our calculator. Remember a few days ago when I said, oh, you got to make sure your calculator's in degrees? Well, now we're going to swap it, and we're going to pretty much for the rest of the course leave it in a new mode and not change it back. So I hope you're not taking physics and they're using degrees or something, because you're going to have to remember to go back and forth. So find your calculator and learn how to change the mode. For me, I go shift and I hit the mode button and it brings up a setup, and I get 3 little options here. In fact, I can show you if I do this. Hey, what's going on? Okay. And so you can see that I've got number 3 is degree, number 4 is radians, and number 5 is this thing called gradians. That's a third one, but that's a different kind of unit used for something specific. So I pick 4 to put my calculator in radians, and then I'm good to go. And here's what we're going to do. We're going to take our, everybody got that? You try with your calculator. Everyone's different. There was somebody from the morning class, we couldn't figure out how to fix your calculator, which is crazy because I almost never can find a calculator that I can't figure out how to do, right? But we couldn't do it, so I'm sure it's easy. Sometimes there's just a button and you click it and it cycles through, or sometimes you have to go into the settings. Everybody got it on Radians? If you don't, ask me later. I'll come around and help you. When you start a test, here's what you're going to do. You're going to go cos shift pi, or pi, divided by 3, and you're going to hit equals, and you're going to get a 1/2, or 0.5. And that's what is a check that you're in the right mode. Of course, you can look at the little r, but it's also a good idea to check and make sure by punching something in like that. Just get in the habit. My goodness, I have seen people go through an entire test, an hour long, with their calculator in the wrong mode, and all their answers are wrong. It's so unfortunate. Not all, because a lot of them we do without calculator, but you know what I mean. Like, it happens, right? So double check, get in the habit of it. Now do cos of 4 pi divided by 3. What'd you get? Huh? Negative 0.5. Wasn't that our answer that we got? Right? So you can use your calculator to check. By the way, we have a quiz coming up on Wednesday. That's our plan. And it is very likely to be a no calculator quiz. So you do have to learn how to do this without a calculator. But if you have one, you can use it to check your answers. You can check them on the sheet too, but it's nice to have to check along the way, right? Any questions about that? Yes?
Wait, so you're saying we can use our calculators to check on the test?
No.
Oh, okay.
While you're practicing or doing other questions. There are other questions where it wouldn't just be a final answer like this that you can check on the sheet. So you might have to check things along the way, so you could use a calculator for that, but not on a test. By then, you got to be confident and be able to do it. Okay, so we got negative 1/2, so I think we're good. That's how we show our work. This step is necessary to show as part of your solution. I want you to try the next one, actually. I'm going to walk around quickly, not take too long. See if you can at least get it started. Okay, what's the first step? Try to think about it, because this is a little bit of puzzling and problem solving, and just getting started is sometimes the hardest part. So see if you can figure out what you would do at least to start. And if you do have a calculator issue, I can probably help right now.
So to change it, you just hit stop. Yeah, I got 0, and then 1 for Radians. Set up. I think it's 1. Yeah. So do you want to be in norm or norm 2? And that's, I think the difference between those is it's going to give you a fraction answer or a decimal answer, one or the other, I think.
Okay, let's try this. If you're stuck, that's okay. If you're not stuck, some of you are done, some of you are still working, and some of you might not even know where to start, and that's okay. That's kind of where we're at, right? We've only done one example, for goodness sakes. How did you start? What did you do to start?
I converted to degrees. Right?
Converted to degrees, and what is it? 420. Sounds like a lot. 210. 420, you got double that. That's interesting.
Oh, I wrote it wrong.
That's okay. Oh, I see. 210. Okay, good. What are we going to use that for? Why do we care about that? And why? What's the diagram form for? What's it going to tell us? Good, and the quadrant that it's in, both of those things. So how could we do that without the 210? So we know which one it's going to go into, but how could we do it anyway? Well, let's see if we can help. I know that this would be 6 pi over 6. So I am one more than that. Mm-hmm. You tell me. What's 270 you mean in radians? What is 90 in radians? So 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. Pi by 2, pi, 3 pi by 2, 2 pi. But I think of it in segments. That's how I do it. Because if I know 3 pi by 2, then I say, is 7 pi by 6 more or less than 3 pi by 2? And that's harder to do than just thinking of it in segments. So what I mean by segments is I would go like 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6. Yes?
Did you also tell us in the third quadrant because of 7 over 6 is bigger than
That absolutely, beautiful, exactly. But that only tells me it's in one of the bottom two.
Like, wouldn't it be in the fourth or in
The third,
section?
yeah.
It's just closer to double than that.
Absolutely. But like, there's a wishy-washiness to, I think that's going to work for you. I think you're going to be able to tell, like 11 pi by 6 is almost 12 pi by 6, so you're in the fourth quadrant, for sure. But like, we also maybe want to know how to figure it out exactly as opposed to just kind of like, it's about this or something. I don't know. You think so? Okay. So what is my related angle? Pi over 6, because I went to 6 pi over 6 and I got one more pi over 6. Whoops. Okay, so that means, and sine is negative there, because tan is the one that's positive. So that means this is equal to negative sine of pi over 6. We okay with this? So I go up and I figure out, I use a triangle to figure out pi by 6, and that would tell me that pi by 6, sine is opposite over hypotenuse. So that means it's 1 over 2 again. Turns out the answer to every question in trigonometry is negative 1 over 2. That makes it easy. Okay. Everybody okay with that? Cotangent of 3 pi over 4. What do we know about cotangent? Reciprocal of tan, very good. So obviously this is equal to tan of 4 over 3 pi, right? No, it's not. Are you kidding me? Oh my gosh. No. Sorry. Get a little upset about that one because it's a common mistake, but it's really annoying. What? That's like if I had cotangent of 70 would be the same as tan of 1 over 70. 70 is like, you know, a moderately big angle. 1 over 70 is like the tiniest little slice of pie you could ever possibly have. But that doesn't make any sense. Why would those two things be related? That's not how this whole thing works. If tan is like, it wouldn't be, what would it be? If tan is 1 over root 3, cotan is root 3 over 1. That's not the angle, that's the ratio, that's the result. Don't make that mistake. People make this mistake though. It makes no sense to take a reciprocal of an angle. I can't even imagine a time in mathematics where we'd ever do it, but there probably is one, and I'd probably be made to eat my words if I said that it'll never happen. It's probably happened somewhere, but it doesn't happen in high school ever, ever, ever. Okay, please listen to me carefully. Do not make the angle a reciprocal. We'll do the reciprocal in a moment. So what do we do with 3 pi over 4?
We check which quadrant it is.
We're going to figure out which quadrant it's in, and do you know?
Yeah, second.
How'd you get that?
Because it's 1 less than half, or like it's not 180.
So now we're thinking in radians, right? So we go to 4 pi over 4, but we got to back it up a little bit. Back it up a slice to 3 pi over 4. We're not at a whole pi. We only have 3/4 of one. So I'm right about there. So 3 pi over 4, and the related angle is going to be pi over 4, which is 45 degrees. So I know I'm like halfway, so I'm starting to make these connections, and I'm kind of starting to see it a little bit already. See how fast it happens? And we're just scratching the surface here. Okay, so I've got 3 pi over 4 going all the way here. But my related angle here is pi by 4. See how awesome and useful it is to visualize this stuff, just a little sketch off to the side. It's not a necessary part of your solution. You don't need to show me the sketch. But it's really helpful, especially when you're learning this stuff until you're like awesome at it. Okay? And it's also awesome to practice these little tricks, because then all of a sudden you get some kind of wacko question that's different, and you have something that you've done before to fall back on. And I can guarantee you that is going to happen in this course and in your future, where like, oh, I don't need to draw that, but then you don't learn how to draw it, and you come up to a question where you need to, and you don't know how, right? Okay, so we've got a related angle of pi by 4, and we've got cast. And cast tells me that this is negative in that quadrant. So this is equal to negative cotangent of pi over 4. And here's our reciprocal, folks, which is equal to negative 1 over tan. But the angle does not flip ever. Yes? Cotangent is positive in the same places where tangent is positive, because you're just flipping them. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Otherwise, everything else is the same. Tan of pi by 4, I go up here, and I see that I have pi by 4. And like I said, it's opposite over adjacent. So it's 1 over 1. Where am I? So you don't have to show all these steps, that's for sure. Equals negative 1 over 1 over 1, which, oh my goodness, is just negative 1. Punch that into your calculator. You can't do the cotangent part, but you could do the tangent part. Tan of 3 pi over 4, you're going to get -1 for that as well because the reciprocal is the same. Okay, try it if you want to just check. The only 2 steps you would be required to show is this one and then that one. The other 2 you don't have to. Okay, I want you to try this one. Go for it. 11 pi. Ooh, that's missing. I didn't notice that before. 11 pi by 6.
Absolutely. Sometimes they have to.
What's our first step here? What's our first step? Let's figure out which quadrant it's in. And who has an idea? How'd you get that?
So it's 11 by 6, so you have 12 more there, so it's going to be 2 pi.
Yeah.
So twice it equals to 360, so 1 less than, so it's going to be.
Beautiful. Very nice. What if it was 13 pi over 6? It'd be in the first quadrant. You'd just be a sliver more. You've gone all the way around once and you went back in. Can that ever happen? Yes, that can happen. Absolutely anything can happen. Right? Totally, totally. So, very good. So we are here and we're 1 pi by 6. So my related angle is pi by 6. What else do we need to think about here? If it's positive or negative. And so cast. So is it positive or negative? Which one? How do we know? Yeah, reciprocal of sine. Very good. Yeah, so this goes with sine, so it's like the same as sine. So we can do that. We can even do that. We can go, this is equal to, so we got -1 over, we got the whole thing, sine of pi by 6. We already did sine of pi by 6. Do you remember when we did that? It's right there in front of you probably. What was it? Yeah, well, the answer was -1 over 2. Sine of pi by 6 is a half, is positive a half. So we've got the -1 over 2. And we looked at this yesterday, so it should work out to -2. Okay, we're going to push forward because we've got a lot to do. We only have 20 minutes. -2. What's this question saying? Sine of 3 pi by 4 times the secant of 4 pi by 3. So there's nothing different here, except in one question you got to do what we were just doing twice, and then you have to multiply and simplify. Okay, so let's get that started. And this is where it does pay if you can do things a little bit more quickly and start thinking in radians and not always be converting, because some of the questions might have 3 things to multiply or even 4 things or 2 sets of 2 and you're adding, like it starts to get a lot more, right? Okay. 3 pi by 4 is in which, I'm doing the first part here, sine of 3 pi by 4. 3 pi by 4 is in which quadrant? Same, yeah. Second quadrant, how'd you get that? Yeah, swing up to 4, then you got to go back just a little bit. And so that's where sine is positive. So this is going to be equal to sine of the related angle of pi by 4 times secant is 1 over cos. 4 pi by 3 is in which quadrant? Third quadrant, and cosine is going to be negative there. And the related angle is going to be pi by 3.
Wait, isn't it the third quadrant? Oh, yeah.
Are we good so far? If you need to draw diagrams, if you can't do it that fast, I'm going a bit faster because we got a lot to do. If you can't keep up, that's fine. We're going to spend Monday on this as well. You'll have time to work in it on the weekend. It's the same thing. We didn't draw the diagrams this time, but it's the exact same process. Okay? Does somebody have a hand up? Yeah.
So it'll always be pi with 4 or pi with 3, whatever.
For special triangles, we only have pi by 6, pi by 4, and pi by 3. Those are it. That's not the only numbers that come up in the course. There are other ones. But for special triangles, those are the only 3, which is what we're working on kind of right now. Does that make sense? Okay. If it was something else, then you're not talking special triangles and you're solving it a different way, which we've seen a little bit of already. Sine of 90 when you had to do that. Something like that, right? Okay. What is the sine of pi by 4? If I'm not sure, I go up to my special triangle. Oh, that's in this one. So there's pi by 4. Sine is opposite over hypotenuse. So that looks like 1 over root 2 to me. Do you agree? And then the next one is negative 1 over, what's the cosine of pi by 3? That's the one that, oh, I don't think I talked about this. Did I say this? That's a really good one to memorize. Cos of pi by 3 is a good one to memorize for one reason. Punch it into your calculator. You get, who knows it? A half, and you know your calculator's in the right mode. You got that one memorized. And honestly, if you do all the work and you're kind of on the ball and you're getting this, you'll memorize almost all of them. This is how I've done it, just by accident. I know cos of pi by 3, cos of 60 is a half, because that's my calculator trick. That means the other one, cos of pi by 6, has to be root 3 over 2. That's the only other option. And sine is just they're flipped. So sine of pi by 6 is a half, and sine of pi by 3 is root 3 over 2. Like, we just kind of get them, right? But you got to be able to show your work, and you got to be able to do it anyway. So if you're not there yet, that's totally fine. But this is 1/2. I'm going to simplify this to 1 over root 2 times negative 2, right? 1 over a half. The reciprocal of a half is 2. And this is negative 2 over root 2. Now that answer right there is done and fine. You can stop there. But I'm going to show you a trick, and I'm going to show you why you did this in grade 11. And if you choose to do this, I think it's a nice thing. I think it's a good thing. You're going to see why we do stuff like this. When we reduce fractions, why do we do it? It's easier to compare fractions when they're in lowest terms. And it's easier to work with smaller numbers. So what is reducing a fraction like this? It's called rationalizing the denominator. And you might have seen in some of the solutions that they're rationalized. Okay, you don't have to do that, but how would I do that? Do you remember this from grade 11? You multiply by root 2 over root 2. What does that accomplish for us? It goes like this. 2 times root 2 on top. And what's root 2 times root 2? 2, thank you, right? It's better be. That's like root 2 squared. They're opposite operations, so that's 2. And what happens here is I get this. And instead of negative 2 over root 2, I find out, oh, that's just negative root 2. That's a much nicer thing to work with, isn't it? This is why we simplify, folks. I had a fraction. Would have been nasty to work with. That's better. Okay? Questions? Yes?
So on a test, we would lose marks if we didn't continue.
No. Yeah, you don't have to rationalize denominators. In fact, sometimes we say don't, because the calculators, if you have a calculator that gives you fractions, it'll give you the rationalized version. But we want to see that you're doing it, not just your calculator. But we also just say no calculators to bypass that. So anyway. All right, we're going into a different kind. The other kinds where sine of an angle, it gave you the angle. Look at this question. This question is asking for the angle. I have no idea why, but ever since I've been using this program, it's complicated, but when I put my notes into this program, it'll randomly not print part of a line. Or sometimes it's like a word or like a character. It's so bizarre. So this is supposed to say 1 decimal place. If necessary. Sometimes it's not necessary. So these questions are a little bit different, similar in that we're doing detective work. We're still thinking about quadrants. We're still thinking about related angles, but we're finding that information in a different way because we're given different information, right? So what might we do first? There's no rule to this. What would you do first? What would you do first?
I would look at my special triangle and find the angle that relates to what I'm doing.
So which of the two triangles has a 1 and a root 2 in it? Whoops, that was terrible. Pi by 4, 1, 1, root 2. You've already got it drawn, but it can be helpful again to memorize these and label them if you kind of draw them a few times as you're doing your work, right? Every time you flip a page, maybe draw them again, something like that. So that one is the one it's got to be. So it's sine is opposite over hypotenuse. So we're talking pi by 4 here. So our related angle is pi by 4. We're looking for theta. This isn't theta. It's the related angle. So I label it that way, but that's what we're looking for. So that's part of my solution, is to state the related angle. You must. Okay, you must state the related angle before you start solving anything else. Some questions you don't need to find the related angle. That's different. But if you're using a related angle, you must. Next, what do I have to do?
Shift the sine inverse. Pi by 4.
What do you mean by that?
Shift the sine from over there and you can find the theta from that.
Oh, I see. I think we've already done that because we got the pi by 4. I think I understand what you're saying. What do you think, Isaac? How would you do that? Yeah, so for this one, this is the one where we're going to have more than one answer. And how did you know that? Because sine is negative. And where is sine negative? In those two quadrants, not those two. So we're in the third quadrant or the fourth quadrant. So now I can go ahead and I can say theta in quadrant 3 is what? How'd you get that?
Because it's going to be 1 more than a 4 power 4.
Right, so this is just like those little formulas, 180 minus, 180 plus, 360 minus, except now it's not in degrees, it's in radians. So it's pi plus theta related. Again, you don't need to show these steps, but we're going to write it this time, which is, you might say pi, or you might say 4 pi over 4 plus 1 pi over 4, and that's exactly right. It's 5 pi over 4, and then theta in quadrant 4. Whoops. Again, you might convert to degrees, think about what it is in degrees, and then convert that back to radians. 7 pi by 4, very good. What's the little formula? Yeah, 2 pi minus pi by 4. Or sorry, I'm gonna do the whole thing. Minus theta related, which is 2 pi or 8 pi by 4 minus 1 pi by 4, 7 pi by 4. Very nice. I'm going to let you give this one a try to get started.
opposite of adjacent. Which also means cotangent
Oh,
of
because
adjacent.
it's one max.
So which one is adjacent to the opposite?
Okay, so then it's like, okay,
If you do this tan, then you just have to remember like that. So tan, which opposite of adjacent, which would be
Okay, so how do we start this question?
Look at the special triangle and find out which angle it is.
Good. Which of the two special triangles are we in? And then figure out our related angle. So I'm in this one with root pi over 3 and pi over 6. And this is 1, 2, root 3. Cotangent, okay, I can do this off to the side. You don't need to do this, but you can if you want. Tangent of theta. Remember, it's not 1 over theta. It's just theta. That didn't change. But this part is the part that changes. Remember when I kind of yelled earlier in the class and it was kind of startling? That's where you take the reciprocal right there. But it's not 1 over theta. It's the same angle. Theta is theta is theta is theta. In this question, it's the same. But the result, the ratio, is the reciprocal. So instead of 1 over root 3, it's root 3 over 1. So if I'm doing tan, okay, it's opposite over adjacent. So that would be opposite over adjacent, root 3 over 1. So it would be pi by 3 would be our related angle. If I decided to use cotan, cotan is the reciprocal, so it's adjacent over opposite. Correct? So with adjacent over opposite for 1 over root 3 is still adjacent over opposite. It's still pi by 3. Of course it is. It's got to be. If you didn't quite follow both of those, you just have to know how to do one. So that's fine. So that means our related angle is pi by 3. And cast, cotangent is positive, so it's positive in quadrant 1 and quadrant 3. So theta in quadrant 1 is the same as theta related. And theta in quadrant 3 is pi plus pi by 3, which is 4 pi by 3. Okay, let's try to do one more. Ooh, we might even have time to do 2 more. I just got to make sure there's time for me to hand out the work. How do I do this one? Which special triangle is this, Brad?
You change it into 1 over 1, like negative 1 over 1.
Okay, we could do that. And in fact, if this was tan, that's where you would go, and it would be special triangles. What do you think?
Would it be on the cosine graph?
Why would you choose that?
Because like it's an actual number from the graph. But, like,
Yeah, good.
On the cos graph, it's -1.
Yeah, it appears on the graph. For cosine, it's actually not going to be one of the special triangle angles, because if I look at the special triangles, the only one that's going to give me 1 over 1 is, like I said, tan, right? Because tan is that over that. Otherwise, for sine and cosine, I'm always going to get a hypotenuse. So let's look at the graph. And I've got this. And what does cosine... Oh, shoot. What does cosine look like? Very quickly, so I don't run out of time. It starts at 1, goes to 0. What's the radian measure when I hit 0 there? Radian. See how our brain goes back? It's totally good. I love it, right? That's what we do. Our brain automatically thinks in degrees. Then you convert, and it's pi by 2. Beautiful. So this is pi by 2. And then I go down here, and there's my -1, and that's going to occur at Pi, 180, you said that, right? Same thing. We're still thinking degrees. That's okay. Takes a little bit of time. And then from here, there was our pi by 2, pi. What would this one be? 3 pi by 2. Nobody's getting caught again, right? And then this one would be 2 pi. So what's our answer? There's no. This is the kind where there is no related angle. Theta equals pi. No related angle there. Very last one. How do we do this one? It's not a special triangles question because that number I don't think is in the special triangles. You got to use your calculator. So what we do is we say cosecant goes with sine. Thank you. Very good. I like it. Sine theta equals negative 1 over. This is where we do the reciprocal 2.45667. Take your calculator out. Try it right now. When we punch things into our calculator, we do not include the negative. So you leave the negative out. Shift sine 1 divided by 2.4567. I encourage you to do it too. Don't just take my word for it, what the right answer is. It's always good practice. So my related angle is, I got 0.42 approximately. Strange number, but that's in radians, so it makes sense. If you took any of the radian measures, like pi by 3 or pi by 6, and did the division on your calculator, you'd get nasty decimals. So that makes sense that it looks like that. Okay? And then sine is negative in which quadrants? Cast rule says 3 and 4. So theta is, so in quadrant 3 is pi minus theta related, and theta 4 is 2 pi minus theta related. I'm going to leave those up to you. I'll try to write the answers down in a minute, but I'm going to hand out the practice. This will not be on the quiz when you don't have a calculator. But it may very well be on the test where you will have a calculator. Yeah. Yes, it is. Sorry. Yeah. Great, good catch. What was I thinking? The formula there is wrong. The first one should be pi plus theta related, right? And I get 3.6 and 5.9. Is that what you got?
So we can write it down as decimal? We don't have to leave as exact?
You can't for this one. We don't have exact answers. That's rounded. The 0.42 is rounded because we put it in our calculator. For the other ones, don't you dare take pi by, like 2 pi by 3 and turn it into a decimal. Don't you dare. That's the ones where it's exact and you got to know that it's exact. But for the other ones, no. Yep. I don't think there's a normal. It'll say.